Okay, we're going to go ahead and start chapter 5, Foundations of Number Theory. It's important to know, again, some of these ideas here you will be teaching with students. And then some of these ideas are just to push you, right? To push you to have a deeper understanding so that as we study number theory, right, you're going to see maybe some of it's abstract, but really, again, it's about building a deep, flexible number sense that allows you to recognize patterns, make connections, and in the future respond in meaningful ways to your students, and then help them develop a mindset towards exploration, discovery, right? So, again, while your students may not yet learn the formal number theory that we teach here in this chapter or what is taught in advanced mathematics, right? But your ability to recognize its presence in their reasoning will help guide them towards mathematical confidence and curiosity. So keep that in mind as we jump into some of the things here for this chapter. Hopefully, again, get a chance to maybe read the story here or play the song that exists here before getting started. So let's go ahead and take a look at the beginning here, chapter 5.1, primes, composites, and divisibility. So we won't get a chance to play this. If we were in class, we'd have this short exploration. It would bring out a bunch of like little rectangles or squares, and then try to kind of go through this and build rectangles um, with the different number of tiles. And what turns out is if you try to build rectangles, you have a kind of a pattern. And you will see here that there's only certain numbers that produce, in this case, what we call sticks, these long sticks. Certain numbers produce squares, and then certain numbers like 6 here produce multiple rectangles. It can be sticks and other dimension rectangles. So turns out the sticks are what we call prime numbers, and that's what we'll jump into here. So when looking at our notes, prime and composite numbers, right? So we start with a counting number with exactly 2 different factors. That's called a prime number. And we're going to learn again how unique and special these numbers are. We're going to learn that they're the building blocks of all other whole numbers. And so a prime number will investigate. And then if it's not a prime number in this case, we think about a composite number, which is a counting number with more than 2 factors, and that's called a composite number. Remember, these factors are the numbers we use to multiply together to get a product, right? So for the factors of 6 are 1, 2, 3, and 6. 1 times 6, 2 times 3, and so forth. We're not also able to do the activity here, the sieve activity that in the history of math that was used to kind of find prime numbers in a kind of a systematic way. There's a YouTube video in the textbook here that you may want to play. If you have time, I encourage you to play it so you get a sense in the wonder of the history right here of how to find the prime numbers there. So keep that in mind. Before we do this first example, which is really just a factor tree, you may remember that by, we introduced what's called the fundamental theorem of arithmetic. Sounds important, right? Fundamental theorem. Each composite number can be expressed as the product of primes in exactly one way, except for the order doesn't matter, but they're a unique set of prime factors that every number has, every composite number has. And so you see some examples here. What sometimes students struggle with is look like 84, 21 times 4, 7 times 3 times 2 times 2. Ultimately, it ends up what we call a product of primes. And so this product of primes we call the prime factorization. Notice there are multiple ways to start. Like for 32, we could use, or sorry, for 324, we used 81 times 4. For 180, 90 times 2. But someone easily could have said 18 times 10. For 84, I guess we could have done 42 times 2, right? It doesn't matter as long as they're factors. And then ultimately, what we're really interested in is this product of primes, right? And what we mean by that, I'll highlight that for you. When we look at these product of primes, it's here, right? This is the prime factorization, a product of primes. And I even love that term, product of primes. Sounds like a famous rock band or something, product of primes. So that's our introduction. We're going to be focusing on prime numbers, the importance of them. You can see here is that they're the building blocks of all numbers. And then we're going to use these primes in some kind of cool ways to discover other mathematics.